All right, let's review chapters 1 and chapter 9 for the geometry test. So let's take a look at number 1 here. So it says points A, B, and C are collinear. So that means they're all on the same line. And it says point B is between A and C. Okay, so let's kind of draw that out. So let's say here's A and C at the ends, and it says B is somewhere in between. So you could just put B somewhere in between. Okay, and then we're given some information here. It says BC, right, is 2x minus 17. So this length here, BC, is 2x minus 17. They tell us AB is 3, so AB is 3. Okay, and then we're told that AC, so this whole length here is x minus 2, right? So we need to set up an equation to find out what x is. Okay, so we need to set up some sort of equation that makes sense. Well, if you take a look at the diagram, okay, if we take AB right here, and then we add BC, it's going to equal the whole length, right? It'll give us this whole length. So if we take AB plus we add BC, it's going to equal AC, which is the whole length, okay? So let's substitute in the values that we know. So we know AB is 3. We know BC is 2x minus 17. So that's going to equal AC, which they tell us is x minus 2. Okay? And then now we're just going to solve for x. So I'll simplify on the left side. So I'm going to end up with 2x minus 14 is equal to x minus 2. Then we're going to add 14 to both sides. This minus x from the right side. So the x's will cancel out on the right side. The 14s will cancel out on the left side. So we'll be left with x is equal to 12. Okay? Now, in the question, right, make sure you're always answering the question. So in the question, we were asked to find x, right? So once we found x, then we're done. Okay, so this problem doesn't require us to plug in the problem, plug in x to like find a length or anything like that. So we found x, so then we're done. Okay. All right, so let's take a look at number 3 here. Okay, so we need to find the length of NL, right? So we're actually given the diagram this time, right? So you'll notice that if you take right here, if you take NM and then you add ML, it's going to equal the whole length, right? So if we take NM and we add ML, it's going to equal the whole length, which is NL, right? And then let's substitute in the values we know. So NM, to tell us, is 8. ML is negative 4 plus x. And NL is 2x minus 6. Now we need to solve for x. So let's simplify on the left side. So that would give us 4 plus x is equal to 2x minus 6. So I'll minus x on both sides. I'll add 6 on both sides. So I'm going to end up with x is going to equal 10. All right. But in this problem here, we need to find out what NL is. So you have to make sure you plug in the x to find out what NL is. So remember, NL is this whole length. So NL, we were told, is 2x minus 6. Now that we know what x is, we can plug it in to figure out what NL is. So we end up with 20 minus 6. So NL is going to equal 14. Okay. All right, let's take a look at number 5 here. So number 5, they want us to find the distance between these two pair of points. Okay. So first you have to remember the distance formula. Remember the distance formula, all right, is the one with the big square root, where we had to subtract the x values, right, from the 2 points and square them. Then you're going to add that, and you're going to subtract the y values from the 2 points. And you would add these results, right? And they would all be inside a square root. So let's plug everything into the problem. So first of all, this would be like our x1, y1. This is like our x2, y2. let's plug everything in the problem. So our distance will equal, right? So we have -3 minus -1, which is -1. Sorry, x1, which is -1. And we have y2, which is -10, minus y1, which is 0 squared. Now remember, a negative makes this positive. So we end up with -2 squared here, which is going to be 4. Over here we have -10 squared, which is going to give 100. So we get square root 104. Now you have to make sure you simplify this radical. Okay, so I'm going to simplify this radical right here. So our distance we know is square root 104, but I'm going to simplify this, right? So just think of any two numbers that multiply to give us 104. Since it's an even number, I'm just going to divide it by 2. I end up with 52. 52 is another even number. I'll divide that by 2. I'll get 26. 26 is another even number. I'll divide that by 2. We get 2 times 13. So I've just prime factored the 104. Now what you want to look for is a pair of anything. So notice I have a pair of 2's, right? So if I have a pair of 2's, that means that they can cancel and the number 2 will go outside the radical, right? So the number 2 is going to be outside the radical now because this pair of 2's cancels. Now the 2 and the 13 here, they're left over inside the radical. So I just need to multiply them. So 2 times 13 will give me 26. So this would be my final answer, fully simplified. All right, so let's take a look at number 7 here. So we need to find the midpoint of the line segment, and they give us the 2 endpoints. All right, so these are like the 2 endpoints, okay? So what you want to do is use the midpoint formula. So if you remember the midpoint formula, right, you would take the x's and you would add them and divide by 2, and that will give you the x value of the midpoint, right? And then to get the y's, you would do the same thing. Just add the y's, divide by 2, that will give you the y value of the midpoint. Okay, so this would be like our x1, y1. This would be our x2, y2, because these are the endpoints, right? To tell you that these are the endpoints, right, of the line segment. So to find the x value of the midpoint, we take the x's, we add them up, -3 plus -2, and we divide by 2. So we get -5/2. To find the y value of the midpoint, we take the y's and we add them up. So 1 plus -13 divided by 2, we get -12 divided by 2, so we get -6. So we know our midpoint, the coordinates will be -5/2 for x, and y will be -6. Okay? All right, let's take a look at number 9 here. So we need to find the midpoint once again, but this time the problem is just given to us in a different way. So instead of giving us the coordinates, they give us a graph with this line segment. So what we'll need, all right, are the coordinates of these endpoints. So we need to find the coordinates of this endpoint. So this endpoint right here, it looks like the coordinates will be -5, 4. And the coordinates down here, it looks like it's going to be -3, -3. So now that we have the coordinates of these endpoints, we can find the midpoint, right? So find the x value of the midpoint. We take the x's, add them up. So -5 plus -3, and we divide by 2. So -8/2, we get -4. To find the y value of the midpoint, take the y's, 4 plus -3, divide by 2, we end up with 1/2. So the coordinates for our midpoint, x is -4, y is +1/2. Okay? So let's take a look at number 11 here. So this problem's a little bit different because they want us to find the other endpoint. Okay? So they actually give us one of the endpoints, and they tell us the midpoint, and we need to find the other endpoint. Okay? So it kind of helps to draw a picture to make sense of this. So we know one of the endpoints, right? So the coordinates are -5, 8. We actually know the midpoint. They give us the midpoint. The coordinates are 12, -2. All right, so this is the midpoint right here. So we're trying to find the other endpoint, so we can just call this x and y for right now. Okay, so remember this right here is the midpoint. Right, this is the x and the y for our midpoint. Okay, so this point right here is the midpoint. So remember, if we want to find the x value of the midpoint, right, we would take the x's. So in this case, the x's are -5, and then this other x that we don't know right now. So -5 plus x divided by 2 is supposed to give me the x value of the midpoint. Well, we actually know what that is. It's 12, right? So the x value of midpoint, since we know what that is, we can plug it in there. It's 12. Then just do the algebra, multiply both sides by 2. We end up with 24 is equal to -5 plus x. Add 5 to both sides. So we know x is 29. Okay? Now, to find the y value of the midpoint, we just do the same thing. So the y value of the midpoint, right? We're going to add up the y's, right? So 8 plus the other y value that we don't know, divide by 2, is supposed to give us the y value of the midpoint, right? Well, the y value of the midpoint, we know what that is, right? It's -2. So we can plug that in. Multiply both sides by 2. We get -4 is equal to 8 plus y minus 8 on both sides. So we end up with -12. Okay? So we've just found out that the other endpoint is 29, -12. So that means this other endpoint right here is 29, -12. Okay? All right, number 13 here. So we need to find the measure of angle DIJ, right? And then they give us some information here. So first of all, angle DIJ, they tell us is x plus 143. So angle DIJ is this angle right here. So they're saying this is x plus 143, okay? And then they also tell us angle HID is 51 plus x. So HID is this angle over here. So they're saying this is 51 plus x, right? So 51 plus x. And then they also tell us HIJ is 174. So HIJ, right? So angle HIJ, so we're talking about, it tells us this whole angle, right? This is angle HIJ, this telling us is 174. So if we set up an equation to solve for x, right, it looks like if we add these two angles together, right, if we take this angle and we add it with this one, it'll give us this whole angle. So the whole angle we know is 174. So 51 plus x plus 143 is going to equal 174. Let's simplify on the left side. So 2x plus 194 is going to equal 174 minus 194 on both sides. So 2x is going to equal -20. And when we divide by 2, we get x would be -10. Okay, now just be careful, we're not just finding x in this problem, they want us to find angle DIJ. Okay, so it says angle DIJ, so remember angle DIJ is x plus 143. Now that we know what x is, it's -10, we can plug it in there. So now we know angle DIJ is 133 degrees. Okay. All right, number 15 and 16 here. So number 15, we need to find out what angle B is. First of all, you have to recognize when these two lines cross, they form vertical angles, right? Vertical angles. And if you recall, vertical angles we know are congruent. So they're equal. So this is 62, that means angle B has to also be the same, 62 degrees. Okay. Number 16 here. So you notice that this is a straight line, and we know a straight line is 180 degrees, right? So if this angle over here is already 35, if you take 180 minus the 35, it'll give you the rest of this part right here, which is angle B. So that'll be 145. So we know angle B is going to be 145, right? Because together they have to add up to 180. Okay. All right, so let's take a look at number 17 here. So we need to find the value of x. So they tell us this angle here is 223, and then this angle here is 51, and then this angle here is 2x minus 62. But one way to set up this problem is if we recognize that, well, we add everything together, right? It's just going to make a circle, which is 360 degrees. So if we take 2x minus 62, right, plus 51 plus 223, all three of these together add up to make a circle, which we know is 360 degrees. So this is one way to set up the equation. Okay, there are other ways, but there's just one way. So if we simplify the left side here, we're going to end up with 2x, right? Then it looks like we're going to get plus 212 is equal to 360. So we minus 212 on both sides. So 2x is going to equal, right? So if you take 360 minus 212, you're going to end up with 148. So divide by 2. So x is going to equal 74. Okay. So let's take a look at some of these transformation problems, right? So number 19, it says they want us to reflect this shape across the line x equals 1. So anytime you're doing a reflection across a specific line, like x equals some number or y equals some number, what you want to do is you want to actually draw the line. So x equals 1 is going to be a vertical line, right? It goes through 1 right there, right? So there's our line. Then all you really have to do is just count the points and see how far they are from the line. So for example, v here is 2 points to the right of the line. So if I go 2 points to the left, I know that's where v prime will be. Okay. W is actually on the line, so it will actually just stay right there. W prime will actually just be right there as well. U right here is 1, 2, 3, 4. 4 spaces from the line, right? So I'm gonna move 4 spaces. 1, 2, 3, 4. That's where U prime will be. Then T is 2 spaces from the line, right, to the right. So I'll move 2 spaces from the line to the left. That's where T prime will be. Then if I connect all the points, right, I'll get my shape. Okay. Number 20 here. So we want to reflect across the x-axis. So if you remember, when we reflect across the x-axis, we're going to make the other letter opposite. So we're going to make the y values opposite, right? So one way to do this is if we just find the coordinates, right? If we just find the coordinates, right? And then make the y opposite, okay? Or if you want to do it an easier way is, well, the x-axis is going to be this line right here, right? So basically you're going to flip this shape over the x-axis. So if you don't want to find the x's and the y values and make y opposite and plot the points, you could just draw this line right here, the x-axis, and then just count those spaces like we did in number 19. So this is 1 space above this line, so I could go 1 space below, right? That's where I prime will be. K is 1 space above the line, I can go 1 space below, that's where K prime will be. Then J is 1, 2, 3, 4, 5, 5 spaces above the line, right? So if I go 5 spaces below, that's where J prime will be. And if I connect all the points, that's what the triangle will look like if we reflect it across the line, right? The x-axis, okay? Now, when you're doing these problems, remember whenever you're doing reflections, all right, the shapes should not change, okay? So after you do the reflections, the shape should still be exactly the same. So if your shape doesn't look the same, you know that something's wrong, okay? Let's take a look at number 21 here. So they want us to translate the shape 2 units left and 1 unit down. So first of all, 2 units left and 1 down, you have to remember that represents same thing as -2, because we're moving 2 to the left, so that's -2. 1 unit down, so that represents -1. Okay, so what this means is they want you to -2 to all the x values and -1 to all the y values. So that's what we're going to do, right? So for our t prime, s prime, r prime, let's find the values. So all the x's, we're going to -2. So the x here, I'm going to have 0 minus 2. So what's that going to give me? -2. This x over here, if I do 3 minus 2, that's going to give me 1. This x here, if I do 3 minus 2, I'm going to get 1, right? And then the y values, they want us to -1. So if I -1 from the y's here, okay? So from the y's here, I'll do it in a different color. So -3 minus 1, that gives me -4. If I do 0 minus 1, I get -1. If I do -3 minus 1, I get -4. And then all I have to do is plot these points now. So -2, -4, or -2, -4 is right here. It's t prime. 1, -1, 1, -1 is right here. S prime. And 1, -4, 1, -4 is right here. R prime. Then all I'll do is connect the points, and we've got our shape. Okay. Let's take a look at number 23 here, right? So they want us to translate this shape -6, right, comma -4. So if we remember what this means in words, this -6 right here means you want to move, all right, 6 to the left. -4 means you want to move 4 down, right? So since we have this shape here and we already have the picture, we can just take all these points, right? So I could take this point right here, T, I can move it to the left 6 and down 4. So I move it to the left 6, 1, 2, 3, 4, 5, 6, and down 4, 1, 2, 3, 4. So that's where T prime will be. And I'm going to do the same thing with S and R. So move it to the left 6 times, 1, 2, 3, 4, 5, 6, right? And then down 4, 1, 2, 3, 4, right? It's going to be right there. S prime. And then R, move it to the left 6 times, 1, 2, 3, 4, 5, 6, and down 4, 1, 2, 3, 4. R prime, all right? And like I said before, your shape should not change size. Basically, all you're doing, if you're doing a translation, is you're just moving it like right, left, up, down. Okay. All right. So number 25 here, they want us to do a rotation. Okay. So a rotation. So you kind of have to remember the rules for rotation. So they want us to rotate it 90 degrees. So if you remember, if we're going to rotate it 90 degrees, okay, that means we need to switch the x and the y, right? And then we need to make the y opposite. Okay, so what I'm going to do, first I'm going to find these coordinates right here, right? So I have D, right, E, C, and F. So I'm going to find these coordinates here. So D is 0, -1. E is 3, -1. C is 1, -2. And F is 5, -4. Right? So here's my original shape, my pre-image. So now if I'm going to rotate it 90 degrees counterclockwise, I need to apply these rules. So for D prime, E prime, C prime, and F prime. So the first thing I'm going to do, right, I'm going to switch the x's and the y's. So I'm going to switch the x's and the y's. That'll be -1, 0. That'll be -1, 3. I'm going to -2, 1, and then -4, 5. So I've just switched x and y. Now I need to make all the y's the opposite. Okay, so I need to make all the y's the opposite. Now you need to be careful. Remember, you switched the x and the y. This was x and y, right? So now the y is here, and then the x's are here, right? So you're making all of these the opposite right here. So if I make them the opposite, right? So this would be a +1 now, a +1, +2, and a +4. Okay, so you notice these are the original y's. I've made all of these opposite, so that's why all of these are positive over here now. Okay, then I'm just going to plot these coordinates. So 1, 0, right? So 1, 0 is right here, D prime. Then I've got 1, 3. 1, 3 is right here. That's E prime. 2, 1. So 2, 1 is right here. C prime, right? And then 4, 5. So 1, 2, 3, 4, 5 is up here. It's F prime. Okay, kind of move this C prime to a different spot. Right over here. So I've got our shape. Let's connect everything. Okay. So this was C prime right here. All right, so that's all that is right there. Okay. Number 27, they want us to find the coordinates of the vertices, all right, of each figure after the given transformation. So here's our transformation here. So they want us to add 1, right, to all the x's and -2 to all the y's. Okay. So that first, I'm gonna find the original coordinates for our pre-image, right? So we've got Q, R, and S, right? So Q, the coordinates are 1, 3, right? R looks like we've got 1, 2, 3, 3, 5. And S, we've got 4, 3. So now we're going to do the transformation, right? So Q prime, R prime, S prime. So we're going to, they want us to add 1 to all the x's. So all the x's, I'm going to add 1. So I'm going to get 2, get 4, get 5. Right? I add 1 to everything, all the x's, right? The y's, they want us to -2. So if we -2 from all the y's, so 3 minus 2 is 1, 5 minus 2 is 3, and 3 minus 2 is 1. If you want to plot the shape, right, so Q is 2, 1. So 2, 1 is right here. There's Q prime. 4, 3, 1, 2, 3, 4, 3, right here. That's going to be R prime. This was Q prime. Then S is 5, 1, right here. S prime. And we have our new translated shape. Okay.